science and electronics in agriculture, healthcare, and consumer devices. This session is designed to bridge academic fundamentals with real-world technological applications that are shaped in modern society. We are truly honored by the presence and look forward to an enriching experience together. To begin with academic lightning,
Ya kunte kususareha renavela ya tu prevastramrita ya veerambaradandamritgara ya svedpadmanshana ya brahma sankara pravidavi Devani sada vandita samapatu saraswati bhagavati Shishishashamba Uklam brahma vicharesa reparama madhyam jagadyami मीरा पुस्तक धारणी भगयता हस्ते स्वाकी कमालिका विदधति आत्मसरे संसिद्धां वन्दे तां परमेश्वरी भगवती प्रदान सारिधाम
and you we now move ahead with the key presentation ceremony. I request Honorable Director of Rajkiya Engineering College, Banda, to kindly present a bouquet to our distinguished guest, Professor G.S. Tomar, sir, Director, Rajkiya Engineering College, Sonbhadra.
Sì, che me li collega. Me li segnala.
I request Dr. Hussain Singh, sir, to kindly present a bouquet to our Honorable Director, sir. I request Dr. Kumar, sir, to kindly present a bouquet to Head of Department of Life Science and Humanities, Dr. Salim Singh Bhagat, sir. Thank you, sir. We now invite the Head of Department of Life Science and Humanities, so to deliver the welcome address and formally introduce the significance of today's expert lecture. Please, sir.
Respected Director Sir, respected Professor G.S. Kumar Sir, honorable guest, respected faculty members, my dear students. On behalf of the Department of Applied Science and Humanities, Rajkiya College, Banda, I extend a warm and heartfelt welcome to all of you to this expert lecture on from classroom circuits to smart system, science and electronics in agriculture, healthcare, and consumer devices. Dear students, today's program is specially organized for you. Often you study circuits, equations, algorithms, and systems in classroom and laboratories and wonder where will all this be used in real life? How will this knowledge shape my future? These are the questions. Today's lecture will answer exactly these questions. Today's lecture will answer exact answer. We are, dear students, we are living in an era where engineering is no longer limited to machine and devices. It is about solving real problems of society. Electronics today powers smart agriculture saves life through advanced healthcare system and make everyone everyday consumer devices intelligent and efficient. The journey from a simple classroom circuit to a smart real world system being with curiosity, clarity of concept, and guidance from inspiring mentors. It is our great fortune that we have with us today such an inspiring mentor and visionary academician, Professor Tomar, Director, Rajkiya Engineering College, Sonbhadra. Such academic excellence, international exposure, leadership across renowned institutions, and extraordinary research contribution stand as a powerful example of what dedication, discipline, and passion for learning can achieve. Dear students, Professor Tomar's journey teaches us one important lesson. Engineering success is not built overnight. It is built through consistent learning, research, mindset, innovation, and the courage to think beyond textbook. His work story connects class knowledge with cutting-edge technologies, exactly what you need to become future-ready engineer. I urge all students to listen attentively, think critically, and interact freely during the session. Ask questions, clear doubt, and allow this lecture to spark new ideas and ambition within you. Let's today motivate you to explore research, innovation, studies, and entrepreneurship with confidence. I would also like to sincerely thank our respected director, sir, Professor S.P. Shukla, sir, Rajkiya Engineering College, Banda, for his continuous support and vision in encouraging such academic activity in this student learning and exposure. Once again, I warmly welcome our esteemed guest speaker, respected dignitaries, faculty members, students. May today's session inspire you to transform knowledge into innovation and dreams into achievement. Thank you to all of you. प्रेरणादायक हुए ऐसी आशा करते हैं।
Thank you, sir, for your inspiring words and continued encouragement towards academics and technological. We are privileged to have with us guiding force of our institution. I now invite Honorable Director, Sir, Engineering College Banda, to graduate and share his valuable insight.
धन्यवाद। आज मैं अपने संस्थान में इंजीनियरिंग कॉलेज सोनभद्र के डायरेक्टर प्रोफेसर जी एस तोमर का बहुत बहुत स्वागत करता हूं। अपने बिजी शेड्यूल में उन्होंने यहाँ पर आने का आमंत्रण स्वीकार किया। पहले हम लोग वन डे सेमिनार का प्लान कर रहे थे, लेकिन दूसरे एक्सपर्ट कहीं पर और चले गए, जिसकी वजह से हम लोग अभी लेक्चर कर रहे हैं। लेकिन निकट भविष्य में हम प्लान करेंगे कोई ना कोई ऑनलाइन मोड में चाहे ऑफलाइन मोड में एक सेमिनार करने का, एक दिवसीय। आज हम यहाँ पर इलेक्ट्रॉनिक्स से संबंधित ये एक्सपर्ट लेक्चर आयोजित कर रहे हैं। यहाँ पर आज की दिन में अगर आप इलेक्ट्रॉनिक्स का महत्व देखें तो जितना भी सेमी कंडक्टर चिप्स से लेकर के बाकी भी क्रिटिकल कंपोनेंट्स बन रहे हैं, वो कहीं ना कहीं उसमें इलेक्ट्रॉनिक्स इंजीनियरिंग का बहुत ही महत्व है। यद्यपि यहाँ पे इलेक्ट्रॉनिक्स इंजीनियरिंग ब्रांच नहीं है, लेकिन जरूरी नहीं कि प्योर इलेक्ट्रॉनिक्स का ही बंदा वहां पर जाएगा, कोई स्टूडेंट वहां जाएगा। अगर इलेक्ट्रॉनिक्स में आपको नॉलेज है और इलेक्ट्रॉनिक्स सब्जेक्ट के बारे में आपको समझ है कि इलेक्ट्रॉनिक्स सब्जेक्ट मेरे ख्याल से सभी इंजीनियरिंग के छात्रों को पढ़ाया जाता है, तो अगर बेसिक भी इलेक्ट्रॉनिक्स की समझ है तो उसके बाद आगे उस चीज को हायर स्टडीज में परस्यू कर सकते हैं और कहीं भी सीख करके आप इलेक्ट्रॉनिक क्षेत्र में भी अपना जो आपको सर्विस करनी है वो अपनी सर्विसेज वहां पर दे सकते हैं। यहाँ पर एग्जामिनेशन का शेड्यूल थोड़ा सा डिस्टर्ब हो गया, जिसकी वजह से एग्जामिनेशन के बाद कई छात्र घर भी चले गए हैं। इसीलिए आज जो ये एक्सपर्ट लेक्चर हो रहा है यूट्यूब पे लाइव भी दिखाया जा रहा है, और यूट्यूब लाइव का ये लेक्चर जो है बाद में अपनी वेबसाइट पर भी अवेलेबल रहेगा। तो अगर कोई छात्र यहाँ पर यूट्यूब लाइव से देख रहे हैं तो वो भी अपने सवाल पूछ सकते हैं, सवाल अपने टाइप करके डाल सकते हैं और उस पर जो है उनको उत्तर मिल जाएगा। और बाद में भी अगर कोई छात्र इसको मिस करता है तो वो इस तरह के लेक्चरों को अपने जो हमारी वेबसाइट है उस पर देख सकता है। ऐसा हम व्यवस्था करने की कोशिश कर रहे हैं इसमें। और प्रोफेसर तोमर जी के बारे में सारी चीजें डॉक्टर बादल ने बताई हैं। वो कई सारे इंस्टीट्यूशन को हेड कर चुके हैं, और अगर इनके व्यक्तित्व को कोई जानता है तो मतलब मेरे ख्याल से 14 से 15 घंटे तो ये काम करते हैं। और जरूरी नहीं कि कोई चीज करनी है तो उसको ऑफलाइन जाकर के करें, ऑनलाइन भी लैपटॉप पर बैठ करके और मतलब लगातार चीजों को करना, नियमों की जानकारी और बहुत सारी चीजें हैं। मुझे कहने में कोई संकोच नहीं है कि हमारे कंटेम्पोररी करीब 10-12 डायरेक्टर हैं जिनके साथ हम लोग मीटिंग्स करते हैं, बाकी करते हैं, लेकिन हमें सीखने का अवसर तोमर जी से ही मिला। कई चीजें, चाहे वो नियम के बारे में हो, चाहे जो हम लोग की फैकल्टी की स्क्रीनिंग हो रही है उसमें कैसे करना है, ये जो भी चीजें हैं, कई चीजों के बारे में मुझे क्लैरिटी के साथ सीखने का मौका तोमर सबसे मिला। तो मैं उस चीज के लिए भी आभार व्यक्त करता हूँ कि साथ में रहते हुए सीखने की कोई उम्र नहीं होती, कभी भी आप सीख सकते हैं। और एक चीज बहुत ही आवश्यक है कि अंत में हमारी जो मेहनत है और जो कार्य है लगन से किए जाने वाले वही काम आएंगे। बाकी आप कुछ भी करते रहें वो जीवन में कार्य नहीं कर आने वाला है। तो अगर आप मेहनत और लगन से बच्चों काम करते रहेंगे और ये नहीं देखेंगे कि अब हमें ये चीज हमारे काम की नहीं, ये चीज हमारे काम की नहीं, जितने भी चीजें सीख सकें सीखें। मैं आज 59 ईयर का होने जा रहा हूँ जुलाई में, लेकिन फिर भी यहाँ पे रहते हुए पिछले 8 सालों में भी मैंने बहुत चीजें सीखी हैं। और अगर आपके अंदर फीलिंग है, भाव है कि चलिए हमें यहाँ पे रहकर कुछ चीजें सीखने और अपने अंदर कुछ सकारात्मक परिवर्तन लाने हैं, तो वो लाने का बहुत ही अच्छा समय रहता है। आपके अंदर जब सीखने का भाव होगा तो आप सीखते रहेंगे। तो स्किल्स हैं, इस तरह के लेक्चर्स हम पहले बड़े हॉल में सोच रहे थे इसको करेंगे, लेकिन फिर क्योंकि संख्या सीमित थी तो हमने इस हॉल में शिफ्ट किया। लेकिन यूट्यूब के माध्यम से हमारे ये सभी बच्चे जुड़े होंगे जो भी इंटरेस्टेड होंगे, वो इस चीज को सीखने की कोशिश करेंगे। कुछ अपना इंटरेक्शन करना चाहेंगे, सवाल पूछेंगे और बाद में भी सवाल पूछ सकते हैं। और हर लेक्चर से कहीं ना कहीं अगर हमें 4-5 बच्चे भी कुछ सीखते हैं तो हमारे लिए उतना सफिशिएंट रहता है कि उतना भी सीख जाएं और उस पर आगे कार्य करना शुरू करें। तो एक बार फिर से मैं इस उपस्थित अपने जो भी शिक्षकगण हैं, सर कर्मचारी हैं और हमारे विद्यार्थी हैं, उन सबका बहुत बहुत स्वागत करता हूं और आशा करता हूं कि आज का लेक्चर आप लोगों के लिए प्रेरणादायी लेक्चर होगा और आप कुछ ऐसी चीजें सीखेंगे जो आपके जीवन में काम आएंगी।
Thank you so much, Prof, for your inspiring words and continued encouragement towards academics and technological excellence. It is my honor and privilege to introduce our esteemed guest speaker, Professor Geetam Singh Tomar sir, Director, Rajkiya Engineering College, Banda. Professor Tomar sir possesses an illustrious academic background in electronics and communication engineering, with qualification spanning from a bachelor's degree to a PhD, along with a postdoctoral fellowship in future computing from the University of Kent, United Kingdom. With over 2 decades of academic research and leadership experience, he has served in several prestigious roles, including director, professor, principal, and visiting professor, and senior lecturer at renowned institute in India and abroad. He is a senior member of IEEE, fellow of IEEE, author of multiple national books, holder of patents, and has published over 200 research papers in international journals and conferences. Her contribution to advanced communication network, air interface technologies, and engineering education continue to inspire students and researchers globally. So, we are deeply honored to have you with us today. With great respect, I now invite Professor Geetam Singh Tomar sir.
Thank you very much. It's really our privilege to welcome you all in this hall. I pay my respect to Honorable Director, IEEE Banda, Professor Shukla, all my honored faculty members, students, and participants available online through YouTube. It's really wonderful when we talk with the engineers or future engineers. And don't forget, those who are in science in this institute are more than engineers. The day we forget where is science, we will have no technology in the world. So first of all students, whether you are sitting here or you are online mode, the day you think that you want to become an engineer, then what you know and what you do not know, these two things should be in your mind. And first of all, you should be knowing what is science. And how you will know about science? And how you know about science? Because circuits will come and only you know the science. So you should have knowledge of nature. It means that knowledge of nature is called scientific knowledge. Scientific knowledge means your knowledge having physics, chemistry, mathematics. These three things are basic. Biology counts for everything, including us. So that is the thing. But if you do not know about physics of material, chemical reactions of that particular material, and then calculation of those materials, so how you will know? If you do not know about physics, you do not know about chemical reactions, you do not know about the mathematical calculations, then that is use of being called as an engineer. Who is engineer? That is what we do not know. The person who has opposite mindset of nature. If you do not have opposite mindset of nature, then you are not an engineer. Who is good engineer? Who is blunt opposite of nature with compromising in parameters so that it is not impacting on or negatively impacting on environment. So this is the difference between engineer and good engineer. What do you be? Only engineer or good engineer? If you are an engineer, that will not have its own technology. It will remain for entire spectrum of life, either undeveloped country or developing country. It will never be developed. If you have only engineers, those who are already have 1 degree, 2 degree, 3 degrees, in all branches they have degrees, but their mindset is that we need to just explore this nature and we do not give back to this nature. So you will be only engineer. So machines will come from other nations. Those who have good engineers, that is the. This is the only one difference in developing countries and developed countries. Good engineers, they have good involvement. That is academic involvement, not like the Himalayan, where you have all science sitting there. They have their own task. We have our own task. We are more than science for any country. So if you are able to think in that, so we are talking about electronics. So electronics should be taught to non-electronic students more than the electronics students. Why? Because for getting their degree, they will learn everything, whatever is related to their syllabus. And what we will teach you, well, if you are computer science, okay, this ADC subject is in your second year, just to pass it. This subject belongs to Board of Study of Electronics Engineering. It means it is just to pass. No. This is the reason why we do not have any operating system on our country. This is one negative aspect of this mindset which has been injected to your brain by us, being teachers. Because we inject this. In first year, you are being taught electronics, even if you are not electronics student. You are taught with electrical, even if you are not electrical students. You are taught with materials, even if you are not civil students. You are taught about many principles of mechanical engineering, even if you are not mechanical engineer. Right? To give knowledge that you will have to use this, not just to pass. What we have done, being faculty members, we tell, okay, just you pass it, read this unit, this is the unit, and that is easy for me also and for you also. Because I was also taught in the same way that this is of no use for you. If I am a mechanical engineer, that time it was taught, what you will do with valve version, because I mean, those days valves were there for electronics students. What will you do with valves? It is not in mechanical engineering, it is not, it's for electronics engineering. But if that mechanical phenomena or physical phenomena of those devices, if we were knowing, then we would have got our own operating system rather than depending on other countries. So the computer science, IT is available here. How many students are from IT? You will be told again and again by us that this ADC is of no use for you. This basic electronics is no use for you. Digital electronics will be taught to you. Even now, university is helping you negatively by removing microprocessor from mechanical and electrical engineering. It was must for you earlier. Now our university is helping negatively, not positively. Removing the microprocessor, removing the digital electronics, which should be mandatory subjects for other branches, especially for IT and computer science. If you want to program something, you need to know the basic circuit. Now we are at your topic what we have. If you do not know about that circuit, then how you will program for the code for running that particular circuit? Because finally, in any system, what you have? Basic is diode, which is taught to you in first year. And you just learn to pass that subject. You do not read more than 1 hour. Before going to the exam, you will read for 2 hours, 3 hours. And you will pass. If you have come to this institute, passing JE, so even if you sleep, still you will pass. At our time, it was told by our teacher, it is very difficult to fail if you have got into engineering. It's very difficult to fail. So people were trying to get fail, and they were not failing. And those who were trying to get pass, they were failing. Because that time you will not be doing practical. In practicals, most of the students were failed that time. Now who is failing in practicals? Have you ever heard in some institute some person is failed? And this is the reason we are failing in our implementation. Because we do not know the basics of that particular circuit. Another thing, this online system has killed our circuit knowledge. Suppose you are taught with any basic circuit, drawing one circuit, how, suppose this automation is available nowadays, even in your home, you do not purchase a pen for which you have to stand and switch on or switch off. What you want? You want remote in your hand to switch on and switch off. Or just speak to that pen or your devices. But you don't know how it has come. Someone has programmed, someone has designed that circuit. Just for your knowledge, I will tell you, this year, that 25 May, I was in Texas Instruments, Dallas. For 3 days, I was there in that Texas Instrument laboratory. Just I went only for 1 day, I stayed back for 2 more days. Just to see that in our country, what we teach, okay, this PPT teaching, online teaching, then you will have a smart board, which what we call it, interactive boards. So when we go for interactive boards, then finally what we become more sluggish, more lazy, we will prepare PPT at our home. In place of drawing that circuit here, you will just show that entire circuit. That is not the case. So this internet in our all smart classrooms are removed, so that your PPTs which you prepared at your home are not displayed online, and the USB slots are stripped there so that you cannot put USB there. Now you use this smart board. See, in one lecture, 12 years back, I was listening somewhere. He said, okay, we should be accustomed to the latest technology. Latest technology means in place of chalkboard, you should have interactive board. In place of old things were there, you should have newer one. But don't leave the basics. If you are being taught with some circuit, draw it in place of chalk, take electronic pen, and draw that circuit on this interactive board. So that when you go from left to right, it imprints in your brain that how, if you are attentive towards board, if you are attentive towards your mobile, then nothing is helping you. It will never happen. So when I draw, suppose how to switch on this pen remotely, I will draw one circuit here. That will be your brain. Okay, this way, this gentleman went from left to right, how transistor was added, how diode was added. That transistor may be CMOS or anything which is being taught to you. So if you think that whatever technology has come up, even this cell phone you are using, it is made of only one device, and that device is what? transistor is being used as switch, is being used as being used as wire, used and only one device that device is transistor or it may be MOS. That's what we call it CMOS or MOS whatever. So don't forget that whatever has been taught to you in first year is of no use. Say diode function and transistor function, if you know, you can draw any circuit, you can devise any circuit, you can do anything if you know these two devices. If you do not know these two devices, you cannot come up with the mobile set which you have in your hand. So this would be one thing in your mind when you enter into first year. That whatever is being taught to us will be used in future. Another thing, what negative concept we have when we have interaction. Suppose in first year, chemistry teacher will go to teach you. So this is left side equation balance with right side equation. Okay, carry on balancing left and right. So what will become? You will become falsified doing left and right and the right. You will not become. This second right balancing, for what? It means you are also misconcepted that these things we have already learned very well in our schooling. That's why I got 1 lakh or 60,000 rank in JEE. No, that was the teaching, learning, and here it is application. So in engineering, there will be applied. Alone chemistry will not work. Then next teacher will also come. So you have to mix both. Just for an example, because to the system we are talking, circuit to system. If I say there is a fire outside, in that fire, what you know, only two things you know, that either CO2, so you have sensors available for CO2, so you put one, okay, maximum, another temperature, if there is more than this temperature, there should be alarm. And third thing is smoke. Smoke is also there, what you sense, only CO2, nothing else. Or sparking, when there is a electric fire, if more than this luminance comes, it will be recognized as fire. It means only 3 parameters. And for those 3 parameters, you have a sensor around the world. Then if I give you one task. See, this is the practical, and just maybe 1 month or 2 months back, what I heard that, but it is not from, I have not invented this thing. I have heard from somewhere, that's what I am communicating to you. So what was the idea of that gentleman? If I say, okay, other than this, is there any gas which takes less time to react with some material? Whether that material is good enough to flow more current than the current material which is being used currently in that sensor, then what will be the science of it? So what you need for this? Then wait, अब इसके क्या चाहिए? अगर मेरा क्वेश्चन है किसी मटेरियल में अगर लगी कोई एक नया मटेरियल पे आपको डिवाइस कर इसके रिएक्शन इससे जल्दी हो जाए तो अवेलेबल है, कौन सा मटेरियल हो, इसमें करंट कैसे फ्लो हो और कितना इसका साइज होगा या कितना जाएगा, तो क्या क्या चाहिए इसके लिए, आपको क्या नॉलेज होना चाहिए?
सर वो मटेरियल यूज करेंगे जो
आपको उसका नॉलेज कैसे होगा? मटेरियल में बैठा होगा और मेरी माता जी ने नहीं बताया मेरे को कि ये मटेरियल इसके लिए सेंसर के लिए यूज हो रहा है, कैसे पता पड़ेगा?
सर वो तो प्रैक्टिकली करना पड़ेगा।
प्रैक्टिकल कब आएगा? जब थ्योरी करो, थ्योरी कहां से आएगी? मटेरियल के लिए है। अभी मालूम है आपको नया चीज केमिस्ट्री पढ़ाई जाएगी और उसकी जो उसको क्या बोलते हैं टेबल वो पीरियोडिक बोलते हैं वो भी सिलेबस से हटा दिया। ऐसे ऐसे ज्ञानी लोगों को सिलेबस देंगे बट डोंट फॉरगेट पीरियोडिक टेबल। From that, you will come to know that what will be the force required to detach that electron. And material is there which can have more and more electric conductivity if it has more electrons near to your centrifugal force will be less. It means physics, chemistry should be known to you very well. And then for calculation material, mathematics. So this physics, chemistry and mathematics should be taught in such a way that it should look like that somebody, if it is a electronics class, it should look like that someone is delivering lecture of electronics. If it is in IT, it should look like that someone is delivering lecture. And that capability should be there with our teachers. How it will come? It will not come by reading the books, listening the lectures. It will come when you have face to face with older people and users. Where you will find this? When you attend some conferences, you attend some activities, it should not be online. It was just by because that time everything was closed. So even if you attend one such FDP where some good academicians or industry people are coming, industry people will come to give their requirement, academician people will go to give the solution for that requirement. They are experienced enough. So that concept should be there. Even if you do not get that, what we call it, academic leave and paid tickets, is spent from your own pocket. If you are really willing to contribute to this society, because our existence will be there if you are giving something to society. And that existence will come when you will go first time with your own expenditure. Next time, I as director will be ashamed to give you, because next time I will be okay. He has come and some more contribution towards the students. Then that time, automatically from my side it will come. Okay, next time I will give you leave and I will give you money for this. So it means if you are really willing to learn, really willing to contribute, then everyone will help. That is what concept is for academics and learning and teaching. But not go about chemistry and mathematics, and then the material which we want to get out to send another gas from that which takes next time, because there are many places where I was there because that sensor was so sluggish that this alarm didn't reach in time. Because it took more than real time. Even 90% our students are not taught with what is the real time and what is delayed information. What is real time? What is time? Okay, this is available real time. That is the real time or delayed. भैया बताएं कोई बच्चे क्या बताया कि रियल टाइम क्या होता है? कुछ पता है? बताओ बताओ।
रियल टाइम मतलब जैसे टेम्परेचर चेंज हो रहा है तो मतलब हमें पता चले टेम्परेचर
कितने टाइम में?
सर उसमें हम लगा सकते हैं कि
नहीं कितना टाइम है? रियल टाइम का कुछ पैरामीटर है? एक वो है थ्रेशोल्ड, इससे ऊपर है तो रियल टाइम नहीं है।
मतलब सर 10 सेकंड 5 सेकंड
अरे ऐसे बोलने में तो हल्का पड़ जाएगा 10 सेकंड में तो 30 सेकंडों में नहीं है बेटा।
सर 1 मिली सेकंड आई थिंक
This is 50 milliseconds. So whatever internet you get, it is not real time. If it is through satellite, it is not real time. If it is through fiber, it is real time. What is time delay in fiber? For That's why very to get information real time. This is a practical case study which I am telling. That there was firing in Adobe office in San Jose, and the fire system didn't come in time because it is not India. So if you do not come, I think you will be right. If you have come in time, you may not be right. So there was $1 million fine to that particular substation, fire station, because it didn't reach in time. Then there was a statement, why it didn't come. Then it at that time that fiber was not working. That information came through satellite to them, and how much time it takes? 127 millisecond to reach to the satellite, and 127 millisecond to come down, and then 37 millisecond for processing. So how much it takes? Around 327 milliseconds per day. And by that time, it is spread in time. The time they file around the. So there is one another concept, okay, this processing time 37 or 30, because now what happened in that our new student, some engineer came, he put up, okay, I will put one AI model with the machine learning techniques being used. So processing time in place of 37, it became 94 milliseconds. Because as you give algorithm, it will take more and more time. So see, everywhere, everything will not work. You need to know, being an engineer, the where you want to have more and more advanced tools and where you do not want. If you do not have bandwidth enough to send the data, less complex. So there are in your vehicle, you are using here I9, and what is the, because these things are good from your syllabus, so you will still not know. Still, in your own vehicle, the microcontroller is based on 386 and 486. Still, because they do not want to give more and more operating system there, so it takes more time. So by the time your vehicle is sensing something, you are nowhere. So those circuitry which are already available and now which are being used, what software has to be implanted in that? I do people who are designing one software. Until unless I do not know about that circuit, requirement of that circuit, and application of it. If it is an application is to sense in as less as possible time, then there are two methods. One is to have more and more fast material, more and more capability of processing, that's the speed of operation. So whatever this I7 and I5 you see, you must have just, you take previous mobile and today's mobile. Here it was taking operating system by MB, 2 MB, 3 MB, 10 MB maximum. Now if you take 256 GB mobile, in that 19 GB is for your operating system. System software, just if you see the storage of your, see, these are practical things you should know. You are an engineer, the problems will arise from being practical. So 19 GB means it will have to go through some software, it will take more and more time. So it cannot, whether it's real time or not, has to be decided. So now come back to again what we were discussing, the basic circuit to design for having less sensing time with some other material. And that part is rare material available in those countries or those countries. We have abundant of silica. Still, Russian equipment are considered be faster than American equipment. Same circuit if you take designed in Russia, same circuit if you take designed in the US. These are the countries doing us every country in the technological agreement. What is the reason? हाँ बच्चों बताओ नहीं आइडिया यही फिजिक्स केमिस्ट्री और मैथमेटिक्स का सब्जेक्ट है दिस इज नॉट द टॉपिक टू बी डिस्कस्ड इन इलेक्ट्रॉनिक्स और आईटी दिस टॉपिक इज रिक्वायर्ड टू बी डिस्कस्ड व्हेन फिजिक्स केमिस्ट्री एंड मैथमेटिक्स लेक्चर्स आर गिवन आपको पढ़ना क्या होगा ना सिलिकॉन और जर्मेनियम तो क्या है उसमें
because of the free electrons they can easily used in electronics.
Yes. So in silicon, how much voltage has to be given? That's the EV. What is the EV? Junction EV?
But around 3 volts.
नहीं, उसमें है 0.7 जंक्शन वोल्टेज है और इसमें कितना है 0.3. अब वोल्टेज का मतलब क्या है? पीक जाते हैं ना तो कोई अगर मैं आपको बोलूं कि सीढ़ी एक है 1 फीट की और एक सीढ़ी है 4 इंच की तो कौन सा वाला जल्दी चढ़ जाओगे और तो आप परेशान नहीं होगे तो 3 इंच वाले पे पहले पहुंचोगे या 7 इंच वाले पे पहुंचोगे 3 पे यानी कि आपका जर्मेनियम है इट टेक्स ओनली 0.3 EV to 0.3 volt to cross the junction. Silicon takes 0.7 volt. It means whatever amount the silicon, it means the voltage will rises from 0 to 0.7 will take more time or less time. Germanium will take less time or more time, 0.3 less time. And it will take less time. It means any device or circuit made of germanium will be faster than if current is flowing through thick copper and thin copper, it's the same. यही है ना कि थिक में होगा तो करंट ज्यादा होगा भाई उतना ही ले लो आपको अगर सेम वायर ले लो और आप डिवाइस बना लो तो अपनी उसकी कैपेसिटी है जितना रेजिस्टेंस के आधार पर जाएगा तो इसका जो बॉडी रेजिस्टेंस है वो भी कम है तो आई पर आर से क्या आता है लॉस होता है ना तो कौन से में ज्यादा होगा इसमें हीट में कन्वर्ट होगा ना तो ज्यादा होगा तो हीट ज्यादा होगी ना थोड़ी सी और सिलिकॉन में थोड़ा सा कम हो गया इसलिए क्या है कि रसिया ठंडा है तो अगर ज्यादा भी हीट होगी तो उन्हें एसी कम बनाना पड़ेगा और जब इसमें सिलिकॉन में क्या होता है हीट कम जनरेट होती है तो लोग क्या सोचते हैं कि भाई बाकी सब हो पहले हीट कम कर तो किस पे चलेगा सिलिकॉन पे चलेगा ये नहीं देखा कि आगे चल के जब हमारे डिवाइस आएंगे फास्टर एंड फास्टर डिवाइसेस का रिक्वायरमेंट है तो हमें तो पहले इस पर जर्मेनियम पे काम करूंगा सिलिकॉन पे अब लौट के फिर उसी में जाना इसीलिए when you take any microprocessor designed by AMD and designed by Intel these are the two based giant in microprocessor ये सर्किट के बारे में बात हो रही है इस सिस्टम में आते हैं हम लोग ये सिस्टम है ना so heat sink for AMD requirement is more and heat sink for Intel is less then again air conditioning is must for device being using this AMD. If you don't have, then the device liable will go. So this is the reason. Reason is, but AMD devices are very fast. If you take any good, IBM is using those. If you take some good server, the maximum servers which are very fast are from AMD. Or IBM you call, IBM uses both. So you should have knowledge of basic engineering if you really want to have good system. And what we need to do? Read and pass. And when we get good job, it's enough. If we do not get job, then we blame this institute is not. See, institutes are only platforms. Now it is up to you how far you go to dig out the knowledge. If you start digging out the knowledge, then you will be forced upon to read more and more, because if you come with questions, we have to answer. If we do not answer, then standing here, we do not want to be humiliated in front of. So we will go and read again for 1 day, 2 days, 3 days. I can review you by taking many examples of here and there, but not for intensive study. So this is both ways. How much you want to get, that much we will be able to get. So that is what we need to be very careful. If you are really interested in this engineering, then something should be available with you. Jobs will be coming automatically to you, if not here, in some other country. The basic thing, when you come out from your schools, another case history of Harvard, I can tell you. This very recently, 6-month-old Harvard study. What is that? Nowadays in our country, every engineer wants to go to IITs. And for going IITs, you have to become parrot. Then to become parrot, you have to leave your schools. You have to go to those what we call the soaps. Allen soap, Resilience soap. I do not call it them from centers. So what they will teach you? How to crack the JEE? If not, another alternate, you will not have sufficient time. Okay, don't worry, we have a one-on-one school. So the practicals you will get, you don't have to go to school. These are a trend. So you will not go to school, only you will go to write the exams, or maybe possible someone else may also. That is also practical things. And the practical marks list will come from a learning institute to your school. Okay, according to their marking, what you got there, they will start from 30, finished 27, then again from 27 to 30 at random. Okay, this is the practical list which should come to our students. And same marks will get. You are happy that I got practical marks of 30 out of 30, 27 out of 27, but what has been killed? Now it has killed patients who sit in the laboratories. Because earlier in schools, those laboratories were 3 hours, 4 hours, you were made to work. It means that patients are being killed. Now you are coming to first year. So within half an hour, I have done this, because whatever has been given, so the result is available. And now you want to run away from those labs. Labs are to see other groups also, what mistake he has done, so he is not able to perform that particular practical. It is not only the physics, chemistry, mathematics, I am talking about other laboratories also. In that our IIT is also. Earlier, labs were of 3 hours. Now they have reduced to 2 hours. And what is being given to you? Okay, you read the constitution, you read this, read that, read IKS, and if they make us, what the lawyers will do if constitution is not being. It is still something. If we are good enough, somewhere it is required, we will hire many lawyers. Why to spend, I do not call it spend, I call it to waste those 40 valuable hours of your syllabus. Those 40 lectures have been taken out from your practicals. So that, because they know all are coming from those errands and others, so they do not have patience to reduce the laboratory work. This is the study on. We are now weaker in practical when they go to other good industries. And this was the problem given by the exam instruments, that those IITs who are coming, because they are still they are fighting on open device circuit. I went there that day, they were drawing on still on all what we call small pupas where the two engineers are sitting, they were fighting tens together. That no, here this resistance will be put, another one said no, this much current will go. It means they were drawing and then they were implementing that. Still they are using sodium iron. Only thing, because now circuits are very thin, so in place of naked eye, they were using microscope. Sodium iron of very micrometer size. This is the only difference. But still, the final circuits after dip soldering, they use this soldering. Individual circuits they will check, and then finally making entire the instrument. You know that instrument is the world's leading instrument industry. So if you take at least online, you can do it. It means no one else will teach you. If you really want to become an engineer, you will have to take an additional step towards that. So from basic circuit to system, if you come, then and if you leave apart ECM, then neither you will learn about basic circuits, nor you will be able to design any system. That's what the outcome is. So you need to know ECM first, then only you can become an engineer. If these things were so irrelevant, I say, okay, they are so irrelevant, then why still 100 years back or 80 years back, some inventions were there, still we are using the basics of that. Now another example I give you. इसमें कोई कौन सी ब्रांच है सर यहाँ पे आई मैकेनिकल की कौन बच्चे यहाँ बगल में कोई नदी है This river. Okay, I will give you 10 kg of rock iron. One ball of 10 kg rock iron, and I will tell you, okay, you sit on this, cross this river, and I will tie you with that rock iron. What will happen to you?
Definitely you will think.
You will sink. What principle is being used here? Arrangement. सिद्धांत बोलते हैं ना, आज तक दूसरा सिद्धांत क्यों नहीं आया है? हम तो दूसरा सिद्धांत बनाएंगे, मॉडर्न हो गए ना, क्यों यूज करते हैं? जब कैलकुलेशन करेंगे वही क्यों करेंगे? सरफेस बनाएंगे तो उसी टाइम उसकी कैलकुलेशन क्यों करेंगे? तो दूसरा आ जाता। अब क्या, अब आपको देना कोई, हमने बोल दिया कि आपको इफ इट इज 100 मीटर given you that you have to take this 10 kg, you do whatever you want to do as an engineer, and cross this river in 30 seconds. What you will do? ये प्रैक्टिकल चीजें हैं, बताओ क्या?
Sir, you will have to create increase its surface area basically.
क्यों?
Sir, to increase its buoyancy.
तो उसके लिए क्या नॉलेज होना चाहिए फिर आपको?
Basic knowledge of
क्या?
chemistry.
आपको पता होना चाहिए कितने टेम्परेचर तक हमें जाना चाहिए,
Yes.
इसका कितना फोर्स है कि इसका वो ब्रेक ना हो जाए, इसमें वो बैलेंसिंग होना चाहिए ना।
Yes.
यानी इसमें और क्या चाहिए कि भाई कहीं ऐसी जगह पे गर्म ना करें, मालूम पड़ा कि इसकी जगह पे वो बगल में एसिड रखा हुआ है और गर्म भी कर रहा है उसके बाद, यानी केमिस्ट्री का नॉलेज होना चाहिए। और कितना सरफेस होना चाहिए आपके बजट को सहने के लिए, उसके लिए क्या चाहिए? मैथमेटिक्स चाहिए ना, थोड़ा कैलकुलेशन करोगे ना, यानी तीनों चीज यूज होगी। ठीक है, प्लेट बना दी, उसमें बैठ गए तो जब पानी जा रहा है वही ले जाएगा ना।
Then sir, come
क्या उसको आप बोलोगे कि अच्छा ये प्लेट चल, वो चल रही नहीं तो क्या?
then comes electronics we will use.
नहीं, इलेक्ट्रॉनिक्स यूज नहीं करो। इलेक्ट्रॉनिक्स तो यूज हो गई, यानी इंजीनियरिंग यूज कर लिया। यानी अगर देखा जाए तो सबसे पहले हमने क्या किया? गोला था नेचुरल, हमने पहला इंजीनियरिंग ब्रेन यूज किया अपोजिट टू नेचर। ये फाइनली हमने अपोजिट टू नेचर किया ना, उसका सरफेस बढ़ाया, उसको गर्म करके थोड़े ये इंजीनियरिंग ब्रेन यूज किया। अब इसकी स्पीड बढ़ाने के लिए आपके डायरेक्शन के हिसाब से टेक्नोलॉजी यूज करिए। यानी साइंस इंजीनियरिंग और टेक्नोलॉजी का जो डिफरेंस है वो ये है, साइंस है उसकी प्रॉपर्टी जानना, और अगर उसको यूज कर रहे हैं तो कैसे हीट या क्या उसको करके अपने सरफेस बनाना है, वहां तक आपकी इंजीनियरिंग हो, यानी उसके अपोजिट गए। अब टेक्नोलॉजी का क्या है, जल्दी जाने के लिए तो हमने तो दिया आपको 30 सेकंड, तो 30 सेकंड में आप हाथ के चंपू से भी नहीं जा सकते, तो क्या आप इंजन लगाओगे ना, आप लगाओगे, अब उसका गियर लगाओगे, टेक्नोलॉजी, यानी इंजीनियरिंग के ऊपर टेक्नोलॉजी बोलते हैं। व्हाट इज डिफरेंस बिटवीन इंजीनियरिंग एंड टेक्नोलॉजी, and that is what differences from science to engineering. So these three things we should teach the day you enter engineering. That you have to prepare your mindset in such a way that you are able to think like an engineer and work like an engineer. Thinking is engineering and working is technology. So when your brain and hands both go together as per your direction, it means you are technology. If only brain is working, then you are an engineer. So we do not need only brain, that may go negative. We need your brain, your hands according to your brain, and your brain according to need of, and need of society will come when you are social element, not a one room element. It means you have to go around. Then only you will. So when you come out from your home, reach my school, then you will have hundreds of problems. If you think this problem, that problem, this problem, that problem, and come into room, you will fight with someone. Because our problems are in your mind. If you think one problem, and that will be the solution, then it's a positive thinking, and you are an engineer now. And if that person has come out from your minds, then you are. So we need technologists. We are lack of technologists. That's why we do not have any technology program. Good technology, though we have many technologies, but the most required technologies we do not have, either we purchase or buy. That's why we are afraid of it. If tomorrow Google stops its link, where are you? If Microsoft put one in a random bug knowingly, where is your system? Nowhere. So you should be prepared for that. It means the system knowledge will be there only when you have something. And that's why to design any operating system, if you do not know about the diode, transistor, about assembly language program, it means microprocessor. Then certainly this IT and computer sciences of no use. If we do not know that software will be put and where it will be put, how much memory we have to design, what type of circuit we will design, then electronics engineering is of use. Another concept of our academic world of our country has come, multidisciplinary. What is killing us? Multidisciplinary means not that much. If you are multidisciplinary, then you should have good collaboration first. It means those persons who are working in multidisciplinary applications or products, that gentleman has to have both knowledges. Multidisciplinary is at top. It means one branch from this place, another branch from this place, if both are coming on top, third item is available. It means both should have knowledge of both. Not that one is having knowledge of one branch, another is having, and finally in one MS or BTech, we call okay, this multidisciplinary. Just by writing a name, AI and DS is not multidisciplinary. Or electronics with the AI is not multidisciplinary. If you know about AI, if you know about electronics, then only it is AI. And for AI, what you hear nowadays, everything AI. But भाई नए बच्चे ज्यादा यूज कर रहे हैं आज, आपको पता नहीं है क्या ये बीमारी जो AI है? ये तो 1956 से हम लोग सुन रहे हैं, हमने भी पढ़ा कि AI कुछ नहीं। एजेंट, अच्छा ये सबसे अच्छा होता है। अच्छा एजेंट की कितनी इज्जत होती है समाज में? अब बताओ एजेंट की कभी इज्जत हुई है क्या? कोई ब्रोकर बोल देगा, कोई एजेंट बोल देगा, कोई दलाल बोल देगा, यही है ना। सो एआई को मैं हिंदी में दलाल बोलता हूं। क्यों? सी what it is doing. Earlier also it was available, mathematical modeling was available. For AI, mathematical modeling was available. But that was not available. There was no computing power because there was no data bandwidth by which we can immediately fetch data available all around. We didn't have the data available on some servers. It was not available. So even if you have algorithm, how to take all together at one place, process it, and give some result. What AI is doing? Is it doing some new thing? For you it is new, but for the entire world it is old. The something available somewhere, but suppose on particular subject you are taking. Nowadays papers are being written on this. One topic you are given, particular sensor network. So one paper available in Netherlands, another is available in US, another is available in India. Earlier we didn't have any mechanism to see, otherwise you have to write later, okay, what is available at your place. So it will come in 2 months, 3 months, and by that time whatever came into your mind has gone. Now what is happening? You give that model, okay, one paper in this area, what it does? It goes everywhere. And that items it collects, puts it in one already available framework, and it's available. Behind this, what I said, negative impact. This is also another case study and outcome of one study, practical study. If any AI model is being trained, even you must have seen horses. One horse, if you sit on its without training, what happens? You will be somewhere down, or the horse will be above you. Normal nature of horse. What you do? You call one training person, because we had horses in our house when we were young. So that training person will come for 3 months. It will give training, and then after that, if you say whatever you tell that horse, it will go that direction. Even you will not have even any problem in riding that horse, because now it is great. So same horse is this AI. So during training, how much money was spent those days? Per month, he used to charge 1,000 and food and everything. So I'm talking about 70s, 80s. So 3,000 rupees went in his training and 3 months. It means that's also in sort of things you have put up. Now what is happening? This AI model, which is being generating one paper for you, when this gaming was used and designed, it took around 3 months rigorous training for that model on different data sets, types of data, then availability, which source it is available, that directions. It took 3 months. To train one AI model to be used in the world, it consumes lot of energy. And what is the climate problem? More and more carbon emission. So you may go, it may be available, or if it has come on Google, it will come, because it's a 2 months, 3 months back study has been done. If one AI model is being trained for one, it generates or it emits carbon equal to 1.5 liter cars for its entire life. It means entire life is calculated 0.3 million and 3 lakh kilometers. It means 1.5 million kilometer running one car of 1.5 liter capacity generates equal carbon or emits equal carbon. It means this whatever this form in Noida is more than this other Agra or other place. It is not only that dust of whatever we call many regions. This is also because it is also emitting that or the emission is out of data centers are near to big cities. Why San Jose didn't have its data center in San Jose? It is 200 kilometers away from San Jose in California. Because they were knowing this, that carbon emission will be more, so put it in somewhere in first. So that's why, and the plantation was done to counter that carbon. It means whenever we are using our engineering brain and technological hands, we need to think of nature. What impact your product is giving to environment. If you are able to think, then you are good. तो इस पे तो हम बोल सकते हैं, लेकिन आप लोगों को कैपेसिटी नहीं है. See, concept is you have to go out. If you go around, I think you may get hundreds and hundreds of negative, but at least one positive thing. Even when you go, suppose somewhere there is a quarrel, and generally we see, no, don't go there, don't go. You go there. At least you will learn. If you are positive mindset, if you are negative mindset, you will be also part of it. And that is part of our engineers also. So see, any country is being run by engineers and scientists, not by politicians or administrators. That should be in your mind, even if you do not get any what we call it award for that, or maybe we do not get that respect. But we need to be thinking about it. Don't think about your whether you got that particular respect or not. We need to work for satisfaction and for our country. And country can be developed only when engineers are there. No one else. You see anywhere, wherever you put your site, you will see that okay, this is also product of engineer. It means entire economy depends upon you. And if you stop working, what will happen to our country? Nothing. So we need to work for our country, forgetting everything. See, if that time was not today, then today's time will also not be tomorrow. That we have to think. Don't think only for today. Think for tomorrow. How much we can contribute? What can we do for more and more contribution? If not, suppose see, everyone is not able to do everything, then at least in group. So this is what we are working in, learning the leadership, not negative leadership, and be as less as possible corrupt. Corruption is not only money. Corruption is many bad. If you are not doing your degree well, not working for your particular branch or trade, that is also. If you are not responsible towards your parents, that is also. You should be responsible for yourself, for your parents, automatically you will be responsible. So because we have come out from detain, so we think of nation first and nothing else. Not in slogans and lectures. You need to display it. You will put slogans, many politicians are here. They want to run the country on slogans only, but we are engineers. We engineers do something, then someone else is to make those slogans, not you. So what for the country? So from circuit to system, if you really want to go, then all the branches should learn about everything. Nothing is of what we call is less importance. Everything is for your better maneuvering as a. So thank you very much, sir, to have this interaction and let us. कोई क्वेरी हो तो क्वेरी बेसिकली क्या होता है या तो सब आ जाए या कुछ नहीं आए तो कोई क्वेरी नहीं बट सी इवन इफ यू आर एबल टू टेक बैक 10% our task is
यहाँ पे
I am available even for online. I am available at any time and on Google if you put my name you will get my all contact.
यहाँ पर जो बच्चे हैं उनको कुछ पूछ रहा हूँ
किसी भी तरह कुछ नहीं ठीक है फिर आप अच्छी तरह काम करिए और आपका आउटपुट देश के लिए बस ये सोचिएगा क्यों बने क्योंकि देखो उसका नहीं है अभी प्राइवेट यूनिवर्सिटी जितनी है ना आप जाओ में 2-3 कोर्स में था वहां से बढ़ा दिया गया क्योंकि वो फिजिक्स केमिस्ट्री मैथमेटिक्स था एंड आई डिडंट पास क्योंकि भाई हमने कोई सीखा कि आप देखोगे उसमें करीब केवल पढ़ने के लिए या सीखने के लिए मैं जाता हूँ करीब करीब 60-70 कंट्री घूम के आते हैं घूम के नहीं आया सीख के आया घूमने भी जाओ सीखने भी जाओ अकेडमिक इंटरेक्शन के लिए कम से कम 7 देश और तरह तरह के वैज्ञानिक मिले तरह तरह के प्रोफेसर मिले वो सब क्या बोलते हैं कि द डे वी स्टार्ट थिंकिंग इन एनी इंजीनियरिंग इंस्टीट्यूट दैट डिपार्टमेंट्स आर डिस्टिंक्ट branches are distinct then you will be distinct and what you call it next no now if you another thing is when you go to any government institute or private institute the practical things are what they think that other institutes are not advanced if you go to government work we start thinking that private institutes are not advanced so this gap in our country is also killing our country and then pressure of private because they do not want to spend more money so we will remove okay physics teachers are taking more money okay remove physics chemistry are taking more money remove chemistry and we help because we are part of that board of study and we have just removed because we are worried about what he is able to give it to us after when we go after this meeting so that is famous so why we are so in that if you think of even I was in discussion with the even if it is available to word I am not afraid of with some IIT people we were sitting so same thing whatever discussion this physics, that chemistry, then I said, okay, this private people do not do this, they do not do this, state government universities are also able to not do anything. And I said, okay, but if your motive, if you suppose tomorrow is given a chance, then where you should go to teach or to that sabbatical leave is there for 1 year, 2 years. Okay, then I go to Stanford. So this is the private or government. This comes private. It means your countries, I want to go to institute, whether it's a private or government, and here you will teach, okay, this is private university and this is government university. So this difference is also very us. So wherever we go, because I'm talking to you, you are our next generation. This difference you should not take in. 50% of your problem is. Another thing, in science, what we do? You call some experts, especially from, I'm talking to this science people, Israel, Netherlands, or Italy. You call them. And you ask them to teach just for a class. I'm taking one example. Because many times I have called them. And when they will teach Lambda as the mathematician, the people will think, okay, they are talking about language. And the person who is sitting IT person, they will think, okay, they are talking about IT. Just for an example, if I start talking about Fourier series in mathematics, who is mathematics people here? Mathematics people here? Fourier series अलग पढ़ाई है. उनको के Fourier series is this solution, this equal to this equal to this. Your answer is there. But you know the 12th also we also solution is there. If I say this Fourier series, in second year you will have ADC. In ADC you will have modulator. In modulator, how this modulation will take place, that this Fourier series will be applicable. So to reduce the power consumption or to enhance the bandwidth, how you will use this Fourier series and Laplace transform, that will be known. Okay, because it will be used in second year and third year. So they will not go through that Laplace or Fourier series the way we intended. Now it is their requirement. Because in second year when you will come and in that you will experience. You are first year, second year. Second year. So ADC is available. Analog circuit or some subject is available to you. Communication subject is available to you. Very good. This is another related. See, that communication circuit will be used where? In microprocessor. Because when any signal is taken from this environment, if you take, this is analog. It has to be converted into digital. What you have to learn, how you will come to know that how many bits will be used here as a science student. It will be known only if you know the quantization. Quantization is in digital communication and analog communication. Yeah, and quantization is being taught in mathematics. So at the time when this mathematics that unit was being taught to you, if they say, okay, when you will use this conversion of your this parameter, this sensor you will be using in IoT devices, in that temperature is analog, it will be converted into digital using quantization to enhance its resolution. At least 8-bit or 16-bit word will be taken, which will be processed in microprocessor. Then you will get this result. It will be imprinted in your brain like anything. That don't forget this, because after 2 years it will be used, and I will be writing program for that. And the electronics person will say, okay, I will reduce the power loss and I will increase the bandwidth. Mechanical person will think, okay, I will design in such a way it's casing. Whatever more heat is because when processing power is more heat will be generated. So the mechanical person will think, okay, I will add some material and some design by which the heat is easily distributed to the environment. I will design fins in such a way. I will reduce the vibration. I will learn about MATLAB, because I am in MATLAB that it is being taught to you for that. See, this is the concept of engineering. And this concept will come when you interact with the good people around the world. And that's
Thank you so much, sir, for such an insightful and thought-provoking lecture. As we move forward, the conclusion of today's session We are now moving ahead to the moment presentation ceremony. I request Honorable Director Sir Rajkiya College Banda to kindly present a memento to our distinguished guest, Professor D.S. Tomar sir. As we move forward the conclusion of today's session, I invite Dr. Abjit Singh sir to deliver the vote of thanks.
Thank you, sir. Thank you, sir, for your word of wisdom. अगर मैं इस जो पिछले एक घंटे का जो सत्र था, उसको समराइज करना चाहूँ तो एक वर्ड आता है समझ में। सर ने अपने पिछले एक घंटे में इतने सारे अपने अनुभव को हमारे सामने प्रस्तुत किया, जिससे उन्होंने हमारा जो कागज भी जो दिमाग में उसने इतनी सारी प्रॉब्लम होती थी, लग रहा है कि हम बहुत थे या मतलब हमें बहुत सारी की जरूरत है। तो जो हमारी इस एक्सपर्ट की थी मुझे पूरा समझ दिमाग में ये आता है कि हम लोग जो थीम लेके चले थे इस सेशन के लिए, उसमें हम सफलतापूर्वक प्रोग्राम को कंप्लीट किया है। तो मैं वोट ऑफ थैंक्स के लिए हमारे जो एक्सपर्ट हैं आज उन्हें धन्यवाद देता हूँ कि सर ने अपना अनमोल समय हमारे साथ यहाँ पे हमें दिया और अपने एक्सपीरियंस को हमारे साथ साझा किया, जिससे हम उम्मीद करते हैं उन अनुभवों से हम खुद पे भी वर्क करेंगे, खुद पे भी कार्य करेंगे और खुद को भी इम्प्रूव करने की कोशिश करेंगे, जिससे कि जो हमारी जो सर्किट है, जो हमारा सर्किट है, उसको हम इम्प्रूव करके एक बेटर सिस्टम बना पाए, जिससे कि जो इस एक्सपर्ट लेक्चर की जो थीम है वो भी सार्थक हो। तो सर को बहुत बहुत धन्यवाद। साथ ही हमारे संस्थान के कुशल निदेशक महोदय को भी मैं इस मंच से धन्यवाद व्यक्त करता हूँ, जिन्होंने इस एक्सपर्ट लेक्चर को ऑर्गेनाइज करने में मुख्य भूमिका निभाई। सर ने ही सर से कांटेक्ट किया और हमें उनसे आज मिलने का मौका प्रदान किया, उसके लिए सर को तहे दिल से शुक्रिया। और सर अक्सर हम लोग को ऐसे इवेंट करने के लिए प्रोत्साहित करते रहते हैं, तो सर को पुनः एक बार धन्यवाद। साथ ही हमारे प्रयुक्त विज्ञान संस्थान के प्रयुक्त विज्ञान एवं मानविकी विभाग के विभागाध्यक्ष डॉक्टर सलीम बादल जी को भी धन्यवाद, जिन्होंने इस एक्सपर्ट लेक्चर को ऑर्गेनाइज कराने में जो महत्वपूर्ण भूमिका थी उनको संयोजित किया और इसको पूर्ण रूप से करने में अपना अमूल्य योगदान दिया, उसके लिए सर को भी बहुत बहुत धन्यवाद। इस लेक्चर में हमारे IEEE की टीम भी इन्वॉल्व है। IEEE स्टूडेंट ब्रांच, हमारे कोऑर्डिनेटर ब्रांच काउंसलर डॉक्टर हुसैन जी भी यहाँ पे उपलब्ध है, उनका भी हमें टेक्निकली सपोर्ट मिला। IEEE की टीम ने भी इस इवेंट को कराने में सपोर्ट किया। इलेक्ट्रिकल लेक्चर स्टूडेंट्स भी लगे हैं जो कि लाइव टेलीकास्ट करने में और इवेंट की जो टेक्निकल बैकग्राउंड होती है उसमें सपोर्ट किया, उसके लिए उनको भी धन्यवाद। हमारे स्टूडेंट जो कि नो डाउट जो कहते हैं कि एग्जाम के बाद घर जाने का सबका मन करता है, फिर भी जो बच्चे हमारे पास यहाँ रुके हैं और इस इवेंट के लिए जो कुछ लोग तैयारी कर रहे हैं, कल भी लगे रहे, परसों भी 2 दिन साथ में लगे रहे, छुट्टी के दिन भी, और आज भी सुबह से लगे हुए, उनको भी एक बार इस मन से धन्यवाद करता हूँ। साथ ही हमारे जो सहयोगीगण हैं, हमारे संस्थान के हमारे फैकल्टी मेंबर्स एवं नॉन टीचिंग स्टाफ एवं जो यहाँ पे उपस्थित छात्र एवं श्रोतागण हैं, उनको भी धन्यवाद कि आपने अपना अनमोल समय हमारे साथ व्यतीत किया। तो आप सभी को सादर धन्यवाद देते हुए मैं इस मंच से इस प्रोग्राम को समाप्त करने के लिए अनुमति चाहूँगा।
Okay, thank you.
I request for group photo. Yes.
Yes, sir.